Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to APS online learning system. I am Jahanzeb Khan with the second lecture of physics class 10th from unit simple harmonic motion and waves. Students, before going ahead, let's have a recap first. In the previous lecture we discussed about oscillation, which was the other term for vibration. Then we discussed about simple harmonic motion, that when a force is directly proportional to the displacement and the direction of force is towards mean position and body is vibrating, it means it's executing simple harmonic motion. Then we proved two examples, motion of a mass attached to a spring and ball system, that these were executing simple harmonic motion. Students, today's lecture is also about simple harmonic motion, and we are going to discuss the third example, that is motion of a simple pendulum. First of all, आपको पता होना चाहिए कि pendulum क्या होता है. Pendulum is a system having a metallic ball with a hook and that is connected with a string and a support. This complete system becomes a pendulum. Now we are going to prove that the movement of the pendulum is also simple harmonic motion. Students, you have to remember that to execute simple harmonic motion, the very first body should be vibrating. Second, its force should be directly proportional to displacement. I am talking about a restoring force, and the direction of force should always be towards mean position. अगर ये तीन बातें पूरी होती हैं यहाँ पे, it means कि pendulum भी simple harmonic motion execute कर रहा है. So let's see. That is the mean position of a pendulum. When we apply force, after applying force, the applied force moves that pendulum towards one of the ends. Let me say A. Here, when we release that object, a pendulum, then restoring force moves that pendulum towards mean position. If the displacement is more, the force I am talking about restoring force वो भी ज़्यादा होगी, and if the displacement is less, the restoring force will also be less. And you can see that the direction of the restoring force is towards mean position. We discussed the first phase. Now let me discuss the second phase. When this pendulum will reach here, it will not stop. ये रुकेगा नहीं यहाँ पे, but it will go towards the next extreme position, that is B. And when it is going towards this position or toward this side, it will again not stop here. ये वापस पीछे की तरफ आएगा और restoring force will move it towards mean position. So in this phase also, the direction of restoring force will be towards mean position. So students, pendulum vibrate कर रहा है, it's okay. The restoring force is directly proportional to displacement, ठीक है, and the direction of restoring force in both the phases is towards mean position. It means कि ये simple pendulum भी simple harmonic motion की example है, execute कर रहा है. Students, अगर हमें time period की value find करनी हो of this simple pendulum, then we have a formula, that is time period, that is denoted by capital T equals to 2 pi L upon G in square root. In previous topic, if you remember, जब हमने mass attached to a spring का time period find किया था, the formula was same, but in place of L there was M. वहाँ पे mass था उस object का जो spring से connected था, and in place of G, gravitational acceleration की जगह वहाँ पे K था, that was the spring constant. Here this L is the length of a simple pendulum की length है, और G is the gravitational acceleration. And student, यहाँ पे एक और बात आप note कीजिए. When this pendulum is suspended, इसको लटकाया गया है, the weight is the force that is acting in the downward direction and tension in the upward direction. So if we talk about the force weight, और हम इसको इसके rectangular components में divide करें, this weight is making an angle theta. When we take that string or pendulum towards this side A, then theta is the angle. So अगर हम इस weight को इसके rectangular components में, I mean horizontal and vertical, or we can say x or y component में divide करें, then we'll come to know the component which is opposite to the angle, that is perpendicular component, and which is with the angle, that is x component, or we can say cos theta. So student, you can see that cos theta is not acting here because the body is moving in this direction. So which component of the weight is acting here? That is mg sin theta. Sin theta is for perpendicular component and cos theta is for horizontal or x component. Now students, we are going to discuss some important features of simple harmonic motion. The very first is a body executing simple harmonic motion always vibrates about a fixed position. ये उसकी पहली रिक्वायरमेंट है कि जो बॉडी भी सिंपल हार्मोनिक मोशन एग्जीक्यूट करेगी वो वाइब्रेट कर रही होगी. सेकेंड, its acceleration is always directed toward the mean position, just like a restoring force, because an acceleration is produced due to this restoring force. And you know, in Newton's second law of motion you were taught, when acceleration is produced due to force, the direction of acceleration is towards the direction of force. So हम डिस्कस कर चुके हैं कि रिस्टोरिंग फोर्स की डायरेक्शन हमेशा मीन पोजीशन की तरफ है. सो द एक्सेलरेशन विच इज प्रोड्यूस्ड हियर, दैट विल ऑलवेज बी टुवर्ड्स मीन पोजीशन. दैट इज द सेकंड फीचर. मैग्नीट्यूड ऑफ एक्सेलरेशन इज ऑलवेज डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट. Just like force is directly proportional to displacement, and acceleration will also be directly proportional to displacement. Acceleration will be zero at mean position and maximum at extreme position. Student, this is called its mean position, and these two A and B are called extreme positions. So जो acceleration है, that will be zero or minimum we can say at mean position, and it will be maximum at extreme positions. The case of velocity is opposite as compared to acceleration. The velocity is maximum at mean. Velocity जो होगी वो mean position पे maximum होगी, and it will be zero at its extreme positions. I mean B and A, these are the extreme positions. Now students, we are going to discuss some terms which are related to vibratory motion, or we can say simple harmonic motion. So the very first is vibration. It says one complete round trip of a vibrating body about its mean position. What is complete round trip? When we release that object from here, it comes to the next extreme position and comes back to its initial position again. It is called its one round trip. So this one round trip from here to here and then to the original position again, it will be called one round trip, which we say a vibration. What is time period? That is denoted by capital T. The time taken by a vibrating body to complete one vibration. इस one vibration को complete होने में body जितना time लेगी, that will be called time period. Frequency, that is denoted by small f. The number of vibrations or cycles of a vibrating body in 1 second is called frequency. Means एक सेकेंड में ये पेंडुलम या कोई भी वाइब्रेटिंग बॉडी जितनी दफ़ा वाइब्रेट कर ले, जितने साइकिल्स पूरे कर ले, दैट विल बी कॉल्ड इट्स फ्रीक्वेंसी. एंड इट इज़ द रेसिप्रोकल ऑफ टाइम पीरियड. मीन्स अगर फ्रीक्वेंसी फाइंड करनी है, सो यू विल हैव टू टेक द रेसिप्रोकल ऑफ टाइम पीरियड. And the last one is amplitude, that is denoted by capital A, the maximum displacement of a vibrating body on either side from its mean position. Students, you can see that is the mean position, its first extreme, its second extreme. So the distance between the mean position and the extreme position, either of this side or this side, that distance will be called amplitude. Now students, let's solve an example. Example says find the time period and frequency of a simple pendulum. हमने time period find करना है और frequency find करनी है. Of a simple pendulum of 1 meter length, and the value of g is 10 meter per second square. You know formula अभी आपने पढ़ा. Length is 1 meter, g is 10 meter per second square. अभी हमने formula discuss किया, that is time period equals to 2 pi l upon g in a square root. So by putting the values, 2, the value of pi is 3.14, 1 is the 1 meter is the length, 10 meter per second square is the value of gravitational acceleration. So after calculation you will come to know that 1.99 is the time period, and the unit of time period is second. Frequency, as we discussed earlier, is the reciprocal of time period. So when you will take the reciprocal of this value, then the frequency will be 0.50 hertz. This Hz stand for hertz, which is the unit of frequency. Next topic, students, is the damped oscillations. What are damped oscillations? The oscillations of a system in the presence of some resistive force are damped oscillation. Means कि जब भी कभी बॉडी वाइब्रेट कर रही होगी या ऑसिलेट कर रही होगी, बट उसको कोई रेजिस्टिव फोर्स स्टॉप कर रही होगी, उसकी वाइब्रेशन को कम कर रही होगी, दैट इज डैम्प्ड ऑसिलेशंस. स्टूडेंट्स, यू हैव टू रिमेंबर कि तमाम वाइब्रेशंस प्रैक्टिकली डैम्प्ड होती हैं, क्योंकि अगर कोई वाइब्रेशन डैम्प ना हो, दैट इज़ एन आइडियल सिस्टम जो कि एग्जिस्ट नहीं करता. जो प्रैक्टिकली हम देखते हैं वो डैम्प्ड होती हैं. मींस कि अगर एक स्प्रिंग मूव कर रहा है या पेंडुलम मूव कर रहा है, तो उसको पेंडुलम को एयर रेजिस्टेंस स्टॉप करने की कोशिश कर रही होगी, स्प्रिंग के सिस्टम को उसके अंदर जो रेजिस्टेंस है वो स्टॉप करने की कोशिश कर रही होगी. सो बेसिकली डैम्प्ड ऑसिलेशन इज़ द ऑसिलेशन अंडर सम रेजिस्टिव फोर्स. और होता क्या है जब डैम्पिंग होती है? जब स्टूडेंट डैम्पिंग होती है, देन द एम्पलीट्यूड, जो एम्पलीट्यूड होता है वाइब्रेशन का, वो विद द पैसेज ऑफ टाइम कम होता जाता है. किसकी वजह से? रेजिस्टेंस की वजह से. बॉडी पहले ज़्यादा एम्पलीट्यूड से वाइब्रेट कर रही होती है, विद द पैसेज ऑफ टाइम उसका एम्पलीट्यूड कम हो जाता है. द बेस्ट एग्जाम्पल ऑफ डैम्प्ड ऑसिलेशन इज दिस शॉक एब्जॉर्बर इन ऑटोमोबाइल्स. आपने कभी देखा होगा हमारी गाड़ियों में जो शॉक एब्जॉर्बर होते हैं. These are the examples of damped oscillations. When a car moves from any speed breaker or any hurdle, then you feel that car starts vibration. थोड़ा सा jolt करती है, vibrate करती है, but within seconds the car or the vehicle becomes normal. Why? Because उसके जो shock absorbers हैं वो उसकी vibration को damp कर देते हैं. Then students, the topic is wave motion. To understand the wave motion, we have two activities. Activity 10.1 is in the figure 10.6. I am talking about this figure. If you can see that we have a container with water. Cork is placed at one end and at other end हम इस पानी को disturb कर रहे हैं किसी पेंसिल या रॉड से. Then this disturbance is transferred up to that cork with the help of waves. पानी move नहीं करेगा, just it will be vibrating, and these vibrations will be transferred to the cork, and this cork will also be vibrating. In second activity, you can observe that we have a string that is supported with one support, and at one end when we jolt, जब हम इसको थोड़ा सा force put करते हैं, इसको झटका देते हैं, then what happens? Loops become in this form, and these loops transfer from one point to the other, and they carry energy with them. So you can see that energy was produced at that end, and that is carried to the other end with the help of these waves. These are the waves which are produced in this way. So students, that was wave motion. Now the question is, what is wave? A wave is a disturbance in the medium. You can see हमने इस medium को यहाँ, water was the medium we have disturbed. Here the string, or we can say the solid was the medium we have disturbed. A medium can also be gas. So when a medium is disturbed, and this disturbance causes the particles of the medium to undergo vibratory motion, and जब हम इसको disturb करते हैं, due to this disturbance the particles of medium, in this case water, in this case string, they start vibrating. जब वो vibrate करना शुरू करते हैं, then this vibration is called wave. So इसका मतलब ये हुआ कि wave basically disturbance है किसी medium में जो vibrations produce करती है. There are two categories of waves. Waves are of two types: mechanical waves and electromagnetic waves. What are mechanical waves? Mechanical waves are waves which require any medium for their propagation are called mechanical waves. Student, propagation means movement. अगर किसी वेव को मूव करने के लिए, ट्रांसफ़र होने के लिए मीडियम की ज़रूरत है, मीडियम कुड बी सॉलिड, लिक्विड एंड गैस, तो अगर वेव को मीडियम चाहिए देन इट मीन्स दिस टाइप ऑफ वेव इज मैकेनिकल वेव. सो एग्जांपल्स ऑफ मैकेनिकल वेव्स आर वाटर वेव्स, यहाँ पे वाटर मीडियम है, साउंड वेव्स, एयर इज द मीडियम, एंड वेव्स प्रोड्यूस ऑन द स्ट्रिंग एंड स्प्रिंग. ये जो स्ट्रिंग आपने देखा या स्प्रिंग की एग्जांपल देखी, इनमें स्प्रिंग और स्ट्रिंग सॉलिड मटेरियल है, तो ये जो है ये तमाम वेव्स आर मैकेनिकल वेव्स. On other hand, electromagnetic waves are those waves which do not require any medium for their propagation. ऐसी waves जिनको मूव करने के लिए एक जगह से दूसरी जगह किसी मीडियम की, सॉलिड, लिक्विड या गैस की ज़रूरत नहीं पड़ती. एंड दीज आर electromagnetic waves which are opposite to mechanical, and the examples are radio waves, television waves, X-rays, heat and light waves. These do not require any material medium. Students, at the end you will be given some homework which you are going to write on your neat notebooks. From today's lecture there will be some conceptual questions. आपने वो conceptual questions solve करने हैं. From review questions there are 2 questions which are related to our today's topic 10.3 and 10.4. From conceptual questions 10.1, 10.3 and 10.4, and in numerical problems you will have to solve 10.1, 10.2, 10.3 and 10.4 with the help of the formula of simple pendulum and the mass attached to a spring, जो time period का formula हमने पढ़ा था, उसकी help से. All these homeworks and assignments are to be done on your notebooks, and after reopening the school these will be checked. So students, that was all about today's lecture. Thank you very much. Have a nice day. Allah Hafiz.